Hi everyone. So today we're going to be going over the Junior Cert Maths paper 2019, the paper 2 version, the higher level one. So with that, I'm going to immediately get started. So our first question is about averages, means, medians, etc. And question 1 says, John measures the height of 8 students in his class, and their heights in centimeters are 141, 165, 167, 168, all the way up to 169, 170, 172, and 172. So straight away we can see that the the number rather, is going from in a kind of sequential manner from here to here. So it's not like 141, 172, 168. It's all the way, it's very clear, the ordering, which is handy for us. So we're going to say work out the range of the data. So the range of the data is the biggest number, and our biggest number here is 172, to our smallest number, and then basically take them away. And that range there is going to be 31 centimeters. So the range is just the highest number minus the smallest number, and that's going to give you the range. Write down which of these heights is an outlier. Well, if we look at 172 to 165, that number is just 7, because 172 minus 165 is 7. But this number is 31. So clearly, this is an outlier to your data. So 141 would be an outlier. As range, you just to give a reason, as range from 172 to 165 is just 7. And that would be perfect answer. Work out the mean of the data. So the mean is the sum of the numbers divided by the amount of numbers. So we can say the sum of x divided by n. And in this instance, it's going to be 172 plus 172 plus 170 plus 169, etc., all the way down to 141. And that, when you put it into a calculator, is going to be 1, 3, 2, 4, divided by, you have 8 of them, so the n value is going to be 8. And in total, the mean is going to be 165.5 centimeters. And that's all you have to do for that one. So now you found the mean of the data. So the next thing we're told, John also measured the height of the teachers in his school. John says, most of the teachers in my school have a height that is greater than 175 centimeters. Okay, put a tick in the correct box to show which of the following statements must be true. All right, so we're looking for the one that's true based on what John says, and tick one box only. Give a reason for your answer. Okay, so I'm going to go through these individually, and by process of elimination, I'm going to come to the answer. So the mean height of the teacher is greater than 175. We can't use this because, so I'm going to just write the mean so that if someone was looking, they'd know what we're referring to. So this is the mean. So supposing we had 160, 161, 162, 163, but then we had, these were our numbers, but we also had like 198. Now, your average might end up being more than 175. But that's because you have an outlier. Like what we had before, where you had an outlier of 141, which might distort your average, or at least what you'd expect to be your average. So the mean is not correct. I'm going to skip the median for a second and just look at the modal. So the mode, supposing we again had 160, 161, 162, 163, and these are our numbers, and we had two numbers, 176 and 176. Now, because these are all singles, this is our mode. Now, this is above 175, but again, it's not really a true representation of most of the teachers being above 175 centimeters. So again, the mode would not be correct for that. And the last one is the median. So the median is like 160, 161, 171, 175, 176, 177, 178. I have 7 here, so I'll go 179 and 180. Now, My median is 176 because that's in between, as the in between value, because I have 9 and this is my in between. So this value is a much better indicator that the average height of the, or not the average height, that most of the teachers are above a certain height. So the median. And I'm just going to put a tick in this box and give a reason. The median is a better indicator that most of the teachers are above 175. And that should be sufficient as long as you have this here as well, because you're completely clarifying your stance. Hopefully that makes sense, and we'll go to the next one. Okay, so in question 2, we're being asked, the following survey was asked as part of, the following question was asked as part of a survey. How do you usually travel to work? Circle one of the following. Walk or cycle, bus or train, car or other. So this is a following question was asked as part of a survey. You don't actually need to circle any of these. Put a tick in the box correct. Put a tick in the correct box below to show what type of data this question would give. Tick one box only. So numerical continuous and numerical discrete are not relevant here because numerical indicates numbers. So that we're looking for either categorical nominal or categorical ordinal. So it's important that you know what each of these means, but essentially your answer is going to be categorical nominal, because categorical ordinal in this instance would be in a range. So the cars were the most used. That might be your A answer. Other might be your B answer. And that's giving them in the order. The categorical nominal is going to be the answer that you're looking for in this instance. So that's your answer. The table below gives information about the way that men and women in Ireland travelled to work in 2006 and in 2016. So here we're given the percentage in 2016 for men, how they travel to work, for women, how they travel to work, and in 2016 for how men and women travel to work. And here we're given the ways that they got there. So first of all, it says, write down the modal way of traveling, as in the mode for men and women in 2016. So we're looking for the mode that they traveled in 2016. Now, if we said for men, if we had 100 men, 60 of those men traveled by car to work in 2016. And if we had 100 men, 71.9 women traveled by car to work in 2016. So your mode is clearly going to be the car. And that's your answer. Complete the table by filling in the following percentages. The easiest one of these very quickly is going to be this, because this has to equal to 100. Because all your percentages together are going to be 100, but also it's very clear because the rest of these also equal 100. Now, for these ones, you basically have to add these together and take them away from 100 to find this value. And this value here is just going to be 2.0. And this value here is going to be 0.7. Because if I added all these up together, 12.1, 8, 62.6, 15.3, I'm going to get 98, and I'm going to have to take away that from 100, which is 2. The same thing with these, 1.2, 71.4, 11.3, and 15.4. If I take them away, or if I add them together, I can get 99.3. Take that away from 100, it's going to be 0.7. And that's your answer. Okay, so the next one says, Evie says in 2006, women were more likely to walk or cycle to work than men. Show that Evie is correct using numbers from the table. So in 2006, so this is the ones we're looking at, women were more likely to walk or cycle. So in this instance, okay, so we can say in 2006, for every 100 women, 15.4 walked or cycled to work. but only 12.1 of every 100 men did the same. So her statement is true. So statement true. And that's kind of all you have to say for that. So what we've done here is we've said that for every 100 women, 15.4 were willing to walk or cycle. For the same number of men, it was only 12.1 in 2006. Alison says more women must have traveled to work by car in 2016 than in 2006. We're talking about most women must have traveled by car. So here we have 71.9 and 60. Because 71.9 traveled by car in 2016, but only 71.4 did in 2006. Is Alison correct? Tick one box only, give a reason for your answer. Well, even though your number here is higher than here, it doesn't necessarily mean it was true, because you could have had 1 million people working here and 500,000 women working here, and this would be a much higher number. It's just a lower percentage out of 100 for what was happening. So the number is not necessarily correct, because you don't know the total amount of women that traveled to work in 2006 versus the total amount of women that traveled to work in 2016. So no, the answer is not completely true. True, as we don't know full amount of women who traveled. Total number of women who traveled in either period. I'll try and write a bit clearer for you going forward. In total in 2016, roughly 990,000 men and 880,000 women traveled to work. Using the figures in the table, work out the total percentage of people who traveled to work by bus or train in 2016. Give your answer correct to 3 significant decimal places. Now, the first thing we have to do is we need to add the two of these values together to find the total number of people who traveled to work. So we know there was 990,000 plus 880,000. That's going to give you the total number of people who traveled to work. So that's going to be 0, 0, 0, 0, 7. So we know that the total number of people who travel to work is going to be 1.87 million. Okay, now we need to try to find out the percentage of people who travel to work by bus or train. Now, for men, the number was 990,000 men, and we're looking for 2016. So it's going to be 990,000 multiplied by 0.83, because it's 8.3%. That's 0.083. Because remember, 100 is equal to 1. 8.3% is going to be 0.083. It's going to be 990,000 multiplied by 0.083. And that value is going to be 82,170. And your other one is going to be 880,000 women. And that's going to be multiplied by 0.105. So 0.105. And that answer is going to be 92,400. So the total number of people who travel to work by bus or train then is going to be the two of these together. And that's going to be 174,570. So now that we found the total number of people who travel to work by bus or train, so that's going to be 174,570 divided by the total number of people who traveled to work. So 1870000, and multiply your answer by 100/1 to get as a percentage. And that's going to give you a value of 9.34%. And that's it. Okay. So hopefully that's all clear so far. Okay, so the next thing we'll do is complete the table below showing the angle in a pie chart for each of the ways men travel to work in 2016. Show your work, give each angle correct to the nearest degree. So for a circle is going to equal to 360 degrees. So the whole amount of a circle is 360 degrees. Now, what we need to then to do is we need to multiply 360 by each of these percentages. So my first one is going to be 12.2% or 0.122. 360 by 0.083. 360 by 0.6. 360 by 0.142 and 360 by 0.053. Just be very clear on where your decimal place needs to go. Always remember that 100% is going to be 1, so 10% is going to be 0.1, 1% is going to be 0.01, etc., etc. So 12.2 is going to be 44 degrees. Now what that means is your pie chart is going to take a chunk of 44 degrees. 360 multiplied by 0.083 is going to be 30 degrees. 360 multiplied by 0.6 is going to be 216 degrees. 360 by 0.142 is going to be 51 degrees. And 360 by 0.053 is going to be 19 degrees. And then it says, complete the pie chart below to show the data in the table above. Label each sector and each of the angle clearly. Now I'm just going to do this pretty quickly, but in an exam, you should probably get your protractor out and do this correctly. But yeah, I'm just going to do it relatively quickly. So 216 is going to be more than 180. So we're going to have some angle like this. It's only slightly bigger than 180. And that is going to be 216 degrees, and it's going to be your car. So your next one is going to be 30 degrees. So 30 degrees is going to be something like that. So we're going to call this 30, and this is bus or train. Next one we'll do is 19 degrees. So 19 degrees is going to be kind of smaller. And this is going to be NS, not stated. Your next one is going to be 51 degrees. And you have another one 44. So this one's going to be slightly bigger. So this is going to be 44. And this one is going to be 51. And 51 degrees is 0.142. So that's other. And the last one is Walker cycle. So we'll just give it in the first digit for each, or Walker cycle. And that's basically it. Again, if you're doing this in exam, I would advise to do it with a protractor. It's going to be more accurate. It's going to look a lot better, but that's how you do it. The diagram below shows the main ways that primary students travel to school from 1986 to 2016. So it's over a 30-year period, and we're looking at the ways that primary school students travel to work. So we can see in 1986, we have some things that were down here, and one of them is getting higher. One of them went up a bit and went lower, and the other one started kind of high and went to the middle. So write a paragraph to describe the information the diagram gives about the ways the primary students travel to school over the period from 1986 to 2016. In your answer, you should use the information in each of the 3 lines. So you have to give information from each and explain what happens over this time period. So I would say, be very factual. Just say in 1986, 50% or roughly 50% of students walked or cycled to school. But this reduced a lot over the last 3 decades. To now on to in 2016 only 25% roughly. So you just put there roughly, you sign. You can say bus or train increased slightly from 1986 to around 1996, but has now decreased to only around 10% in 2016. And then finally, for the last one, you're going to say car. The car was only used by 25% of students. Used by 25% of students in 1986. But now almost 60% of students get a car to school. You don't need to be any fancier, just be very factual with the information that you're going to get with the question. And then that's basically that one done. Okay, so the next one is question 3. It's a relatively short question. And says the coordinate geometry below shows the screen of a digital clock at 1500 hours. The images P, Q, S, and T of this screen under 4 translations are shown as follows. Image P, image Q, image S, and image T. So it basically says, you know, complete the table below to show each image of the transformation that produced it. So I suppose the easiest thing to do is to draw out what each one of those would look like. So I'll do the one up here first. And I'm going to just basically copy it kind of word for, or line for line. So I have 1, 2. This one is at the bottom of this, so it's going to be over here. This, 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 and this. These dots are going to stay the same. Oh. So that would be if I flipped it from that way. If I flipped it this way, I'm going to get this, this. This one is going to be the closest over, so it's going to be like that. And now if I went this way, I'm up here now. So I'm going to have my line for 1. This line is at my top. So this one is going to be here. Now, this one is going to be here because this was on the bottom corner here. So like that, and it's going to be over here. And then my zeros are obviously going to be the same. So now that I have this, this one is going to look very much like S. This one is going to look like Q. This one is going to look like T. And this one is going to look like P. So axial symmetry in the x-axis is going to be S because that's going from here through the x-axis. That's going to be S. Axial symmetry in the y-axis is going to be T. Your translation is essentially the same thing. It's going to look the same as it was here somewhere else. So if I translated it even up to here, it would still look like this. So I hope that's clear. So that one's going to be P. And then your final one, central symmetry in the origin 0, 0. So it was here, and you've picked that point and you flipped it around to get to here. So that one's going to be Q. Okay, hopefully that's pretty clear. So we're told in question 4, the diagram below shows the center circle of a soccer pitch. The center of the circle is marked. At the start of the game, Gary and the referee stand at 2 points in the center of the circle G. At the center of the circle, G and R as shown. So they're standing around here. This is the center of the circle. The referee is positioned here and Gary is positioned here. Okay, so it says Jorge, or Jorge, whatever it is, stands at the edge, stands at the point J on the circle, so that the angle at the referee is 90 degrees. So that J or G is 90 degrees. So some angle here is 90 degrees. Okay, so using only a straight line, construct the point J on the diagram above. Label the point J. So we know that if we have a semicircle, and if we draw straight through, now the 3 points of a semicircle, or sorry, a triangle within a semicircle will have a degree of 90 degrees. As long as this is a diameter. So that is going to be correct. So construct the point J. So your point J is going to be here. So you pick Gary, you went down to here, and you went back for both sides because you know that this angle was 90 degrees. So if you went to here, created that back, this will give you your diameter through the center, bring your points back to 90 degrees, and there's your. And then state a theorem or corollary that justify your construction in part A. You could just say a triangle within a semicircle with 2 points as a diameter will have an angle of 90 degrees. On the other point. Okay, that's that one. So question 5 then, the coordinate diagram below shows part of the town where Clodagh lives. Each small square in the grid has sides of length 1 centimeter. So we know that each of these is equal to 1 centimeter. So that's 1 centimeter, 1 centimeter, etc. Write down the coordinates of the shop, home, and school. So the shop is going to be -3 and 1, because on our x value is going to be -3 and 1. So I'll just put that in here. It's going to be -3 and 1. Our home is going to be x4 and y2. And our school is going to be x4, y5. So I'll just put those in here too, just so that we have them. And our shop is going to be -3, 1. All right, so the library is a midpoint between the home and the shop. Write down the coordinates of the library. So this is just where you need to know the equations for the line. They come up all the time, so it's obviously very important that you can memorize them in the exam. And the midpoint equation is going to be x1 plus x2 over 2, y1 plus y2 over 2. And now so that's your midpoint equation. And now we know we're looking for the point between the home and the shop. So it's going to be 4 minus 3 over 2. And y1 is going to be 2 plus 1 over 2. So our point is going to be 1/2 and 3 over 2. And that makes sense because 4 to -3, if you went back that, you'd be basically 3.5 in that direction. So -4 minus 3.5 is obviously going to be 1/2. And 2 to 1, you're going down 1/2, but you're already up 1, so you expect to be up 1/2. So the answer should be 3 over 2. That makes sense. So next we need to do is work out the distance from the home to the shop. So we're looking from the home to the shop. So it's going to be the equation for the distance of a line. So EQU, distance of a line, is going to be equal to the square root of x2 minus x1, all to be squared, plus y2 minus y1, all to be squared. So I'm just going to sub those values in very quick. So x2 is going to be 4, minus 3 to be squared, all, plus y2 is going to be 2 minus 1 to be squared. So that's going to be all under the square root. This is going to end up being 7 because it's 4 minus 3, so that's 7. So 7 squared plus, and this is going to be 1 squared. That's going to be 1 squared, all under the square root. And that's going to end up being the square root of 50. And the square root of 50 is going to equal to 7.07 centimeters. So that's that bit done. So the next thing we're told is the distance on the diagram from the shop to the school is roughly 8.1 centimeters. So if we were to go from the shop to the school, it's roughly 8.1 centimeters. And we're told the distance is a scale of 1 is to 2,500. So that is 8.1 and the scale is 1 to 2,500. So what we're essentially saying is for every 1 centimeter, so every 1 centimeter, in reality, it is 2,500 centimeters. So if we were to travel 8.1 multiplied by 2,500, because we need to take the value of 1 centimeter, and then it's going to be 8.1 centimeters. You need to multiply it by that, and your answer then is going to be 20250. But it asks us for our value in meters. So every 1 meter is equal to 100 centimeters. Therefore, our value is going to be 202.5 meters. And that's the answer for that, because it asks us to give us the answer in meters. Clodagh walks from school to the shop. Explain why the distance she walks is probably more than the actual school from Partee. Well, she would have to make turns. And 8.1 centimeter on graph is as the crow would fly. And that's it. Okay, so that's that. We'll move on to the next question. So the next bit we're told on 5B, the coordinate diagram below has a line L drawn from the shop to the school. The angle A is marked. So we have the shop to the school and we have a line drawn from the two. Okay, so very quickly, I'm just going to write in my points again. So we have -3 1. We have 4 and 5. And we have 4 and 2. So work out the slope of the line L. So our slope is going to be m is equal to y2 minus y1 over x2 minus x1. So our y2, if we're picking these 2 points, it has to be these 2 points. I'm just going to pick this as my x2, y2. So it's going to be, or yeah, x2, y2. It's going to be 5 minus 1 over x2 is 4 minus 3. So that'd be 4 over 7. Okay. The next bit, find the equation of the line L. Give your answer in the form ax plus by plus c. So your equation to a line is y minus y1 is equal to mx minus x1. Now I have to pick one of these points. So I'm going to pick this one again because it's all pluses. So it's going to be y minus 5 is equal to 4 divided by 7, x minus 4. So I'm going to basically, the easiest thing is just to cross multiply. So it's going to be 7y minus 35 is equal to 4x minus 16. So I just multiply this side by 7. And then, yeah, so then I'm multiplying this side by 7, which gets rid of the 7. So it asked me to give my answer in this. So I'm going to bring 4x minus 7y minus 16 and minus 35 is going to be, sorry, minus 16 and plus 35 is going to be, so use trigonometry and the slope of L to work out the size of the angle A. Give your answer in degrees correct to 1 decimal place. So we know that m is going to be 4 over 7. So the tan of alpha is equal to, or if you don't use alpha, if you just use A or something like that. So the tan of the angle is equal to the opposite over the adjacent. Or tan of alpha, you can just say is equal to 4 over 7. Because in this instance, it's up 4 and over 7. That's one way to do it. But you can also say, if you don't know, tan of m is equal to 4 divided by 7. So m is equal to tan inverse to 4 over 7. Either is correct, but your answer is going to end up being 29.7 degrees, because when you get tan inverse of 4 over 7, that ends up being 29.7 degrees. So just put your answer in here. I'll give it in degrees, and it's to 1 decimal place. Okay, hopefully that's clear. So now we're told the diagram below is made up of 2 equilateral triangles and 2 parallelograms. 3 angles are marked. So straight away, some of the things that we can very quickly identify. This value is going to be K. This value is going to be M. Yeah, so they're just 2 things I've noticed straight away. Write down the correct letter in each of the space below to show how the type of angle each one is. Use each letter only once. So our smallest angle, that's one that's less than 90 degrees, is K. That's our acute angle. Our reflex angle, so that's one that's bigger than 180 degrees, and that's clearly going to be N, because if it was 100 degrees or 180 degrees, it would have to be within this shape here. And our obtuse angle is going to be more than 90, less than 180. So if it was, that's clearly going to be M, because that would be 90, but it's less obviously than 180. So that's M. Work out the size of each of these angles, K, M, and N. Remember that the 2 triangles are equilateral. So we know that the diagrams below is made up of 2 equilateral triangles and 2 parallelograms. So if these are going to be equilateral triangles, it means all 3 angles are the same. So this angle is the same as this angle, is the same as this angle. I also know that it's made up of 2 equilaterals. So this is the same as this, is the same as this. So these angles are all 60 degrees. These ones, that angle is going to equal to M. This angle is going to equal to K. And this one is going to equal to K. Now, if I know that all three angles here is 60 degrees, well then K is clearly going to be 60 degrees. Because it's an equilateral triangle, all the triangles must be the same. So that's going to be 60 degrees, because it has to be 180. Or 180 divided by 3, whatever way you want to look at it. M then is going to be, so that's 60. This is a parallelogram, which means that this length and this length are the same, and this length and this length are the same. But I already know that this is K, so if I do a Z, this angle is going to be the opposite of it. And so essentially, that one's going to be 60, this is going to be 60, the three angles are going to have to be 360, so it's be 360 minus 120 divided by 2, that's going to be 120 each. So these are going to be 120. There's a lot of different ways you could have found that. I just did one of them. And then N. So this angle is 60. Remember that if we're in a parallelogram, this is going to be 120, but this is M. This is the same angle. Now, when I was doing the Z, I did this. But if I went all the way down to the bottom and did this, that would be the opposite of that angle. So, or basically the same as that angle. That was K. This is going to be K. So if I have 120, 120, and 60, this is clearly going to be K as well. So that's going to be 60 plus 60 minus 360. That's going to be 240 degrees. Again, there's many ways you could work this particular thing out. I've just solved it in one format. Hopefully, though, it's pretty clear on what's going on. The most important thing to notice is that it's a parallelogram. So rules apply to that. This is an equilateral triangle. All the angles have to be the same. All the lengths have to be the same. All the angles have to be the same. And you just need to figure out kind of what's going on. So down here, the two equilateral triangles are not the same size as each other. Siobhan says the two triangles are similar, but not congruent. Give a reason why the two triangles are similar. So a triangle is similar if all angles are the same. Sorry, you would say two triangles. If all angles are the same, but not all lengths are the same. Give a reason why the two triangles are not congruent. So congruent is when all three lengths are the same. Okay. Then you said the small triangle in the diagram has a length of 4 centimeters. The big triangle has a length of 8 centimeters. Use this information to construct the diagram in the space below. Show clearly any construction lines used. So I'm obviously just I don't have a protractor, I don't have a ruler. You should do this in the exam, but I'm going to show you how it would be done. So I'm going to pick this point, and I'm just going to start it here. Now, in the exam, I would just, from here, I would draw a straight line through. Just dash that in for now. Here's my starting point. Now I know that this triangle has a length of 4. So I would get a compass and I would swing it out 4 centimeters. So this would be my first. I would get my compass and I would swing it there, and I would get it from here and I'd swing it here, and that would give me my first triangle. Now I know that this triangle is equal to 8. So from this point, I would swing my compass 8. And from this point, I'd swing down 8. And from this point, I'd swing down 8. And I'd get my second triangle. Now I know it's a parallelogram. So this length is going to be the same. And the angle is going to be the same that creates it. So it's going to go up like that. And then I could just, and essentially, I could just draw another dashed line across from here. And wherever they meet is going to be the length of this. Now, this again is another parallelogram. So I'm going to just draw a parallel line to this using maybe a t-square and a set square, whatever you're using. And then I draw another dashed line from here. And wherever they meet is going to be the outer edge of my parallel. And that's basically it. Obviously, this is very rough, but I hope you get the idea of how you would do it in the exam. So that's question 6 done. So question 7, a triangle has side of length 10 centimeters and another side of length x. So we have a triangle and it's going to have a length of 10 centimeters. And it has another side of x. So the perimeter of this triangle is 26 centimeters in length. That's fine. Fill in the length of the third side in each case in the table below. So we just need to identify what the third length of these is going to be. So the first thing we know is it's going to be 26 in total is equal to 10 plus 4 plus, and I'll just put that as a question mark for now. So it's going to be 26 minus 14 is equal to the question mark, and therefore it's going to be 12 centimeters. So this side is 12 centimeters. We have to do the same thing for this. So this is going to be 26 is equal to 10 plus 9 plus question mark. So it's going to be 26 minus 19 is equal to question mark. Hence, it's going to be 7. So that's 7. So I hope that was pretty clear. Find the 3 values of x which make the triangle an isosceles triangle. So we know that the one of the lengths is 10. So if we assume for a second that this was 10, and we know that in an isosceles triangle, 2 of the lengths have to be the same. So I could have a length here. Now, if that was 10, I'm going to have a base of 6. So that's one version. Another version I could have is I could have a base 10. Well, that was going to give me 2 equal sides of 8 and 8 because it's 10, or 26 minus 10 is going to be 16. And I would need to have 2 lengths of 2 sides of equal length to be 8 and 8. So it's going to be 6, 8, and 10. So it's important just to know your isosceles triangle, the laws that govern it, and as long as you can figure that out, that this bit should be pretty easy. The next one, the graph below shows the area of a triangle for all values of x between 3 and 13. So we have, and this is representing the area of a triangle, and it depends on how long your value of x is. So if you have a value of x is equal to 3, your area is going to be pretty small. And obviously as you get bigger, so it's at 4, it's going to be 19. If it's at 5, it's going to be 24 roughly, and then it gets smaller after you get to 8. So A is the point on the graph with x is equal to 4, so it represents the triangle in diagram. Use the point A on the graph to estimate the area. So again, this was the area, this was our value of x, so x was equal to 4, so this point. We go up here, we find our area is going to be roughly 19 centimeters squared, so that should be fine. Okay, so plot the point B in the graph to represent the triangle in diagram B. So this is our diagram B. We know that x is 9 centimeters, so we're going to have to go 9. That's going to be here, and then we're going to go up here. So that's going to be our point B. It's very important not to go from here over to here, which would be 9. You're going from here to here and up. So that's how you do that. And you could even imagine if you drew that, it wouldn't look right. Your triangle to look like that is going to have to go like this and down at that representative angle. So hopefully that's clear. The graph is symmetrical. Draw the axis of symmetry of the graph on the diagram above. So the axis of symmetry is basically going to be through here on 8. Write down an equation. Well, the equation is simply just x is equal to 8. And that's all there is to that. Okay, so we'll move on to the next bit. So in this one, we're told when x is equal to 5, the triangle has sides of length of 10 centimeters, 5 centimeters, and 11 centimeters. So again, if we imagine what we had, we're going to have a graph like this. Our x was over 5, so it's going to be somewhere along this. And it's saying, telling us, prove that this angle is not equal to 90 degrees. So with that, the easiest thing to do is to use Pythagoras' theorem. So we're going to take our biggest one as 11 squared is equal to 10 squared plus 5 squared. And if this Pythagoras' theorem was correct, this side would equal 0 and this side would equal 0. So that's going to be 121. That's going to be 100 plus 25. 121 does not equal to 125, and that is proved. So for Pythagoras' theorem, the hypotenuse should be equal to the adjacent plus the opposite, all to be squared. And in this instance, because we worked that out, we can see that these do not equal, hence the angle is not equal to 100. Sorry, the angle is not equal to 90 degrees. Hopefully that's clear. The diagram below shows the triangle with the biggest area. So this is the triangle if it was shown with the biggest area. And you can imagine that the circle was something like this. So it's right in the middle. Work out the area of this triangle and give your answer in the form of 5, the square root of n cm squared. So the area of a triangle is going to be a half the base multiplied by the perpendicular height. Now, we don't know what this value is, the height. But we do know that this is going to be a 90-degree angle, and this will be a 90-degree angle. And if this, because it's right in the middle, that's going to be 5, and this is going to be 5. So this now very quickly becomes a Pythagoras' theorem. So that's going to be 8 squared is equal to 5 squared plus, and we'll just call this L. So it's going to be 64 is equal to 25 plus L squared. If you're more comfortable with this, I can call it like the opposite or adjacent. I'm just calling it L for this instance. So it's going to be 64 minus 25 is equal to L squared. And that's going to be 39 is equal to L squared, or the square root of 39 is equal to L. And so this value is going to be the square root of 39. So now we need to find this based on this equation. So we know the base is going to be a half of 10 multiplied by the square root of 39. Half multiplied by 10 is going to be 5. Square root of 39 cm squared, and it's in this format, so we're good. All right, I hope that's clear. So this question, I think, is a little bit mean. They've put in some weird numbers to kind of throw you a little bit. If it's going to have square sides, it's going to be a cube if it's a fair die. If it had more than if it was more than 6 sides, it's going to take different shapes in order for it to be a fair die, like triangles, that sort of thing, in order to be a fair die. In fact, I would advise you to Google some examples if it gets higher than 6. But for 6, and it's going to be square sides, it's going to be a die. And the reason I think it's a bit mean is because they've put in odd numbers to throw you a bit, but I suppose that is honors maths. So if we have 7 up here, we're going to have 3 here. 5 is going to be in this side. 4 is going to be here. Our 8 is going to be on this side. And our 1 is going to be on the bottom. So what number will be opposite the number 7 on the die? So opposite number 7 is straight down. That's going to be 1. Yeah, so pretty easy, I suppose, once you figure it out. It's just a case of making sure you understand what's really being asked. So the die is rolled once. Find the probability that the number is greater than 6. So we have 2 numbers greater than 6. So if it's only rolled once, the chances are going to be 2 divided by 6. It's going to be a third. Find the probability. It's like 33.3%. Yeah, I'm sure you could leave it like this probably too, but this is the full probability in percentage. The die is rolled 60 times. Work out how many times you would expect an odd number to be rolled. So we have 1, 3, 5, and 7. So we have 4 divided by 6. So every time the die is rolled, there's a 2 in 3 chance we'll get an odd number. Okay? Or there's a 4 in 6 chance. Well, a 2 in 3 chance is essentially what we're saying. So there's a 2 in 3 chance we would expect an odd number. Now, if we roll it 60 times, that's going to be 120 divided by 3. So 40 times we would expect an odd number. Okay, that's it. The following 3 terms are used when discussing experiments and probability: outcome, sample space, event. Write each of these terms in the table below to match each of its to the description. So I suppose the most obvious thing is to know this, but if you didn't know this, I'm going to give you a way that you could kind of figure it out. So it says the set of all the possible outcomes of an experiment, one possible result of the experiment, and a subset of the sample space, a collection of one or more outcomes. So this says sample space. So your answer clearly isn't going to be sample space. It says a subset of the sample space. This says the list of all possible outcomes. So your answer probably is not going to be outcomes. So provided you know it, this one is going to be your sample space. But I'm just giving you a way that you can not give the wrong answer, I suppose. So it's going to be your sample space, the set of all possible outcomes of the experiment. One possible result of an experiment is an outcome. And a subset of the sample space, a collection of one or more outcomes, is going to be an event. So we had outcomes, the subset of all possible outcomes, a subset of the sample space, a collection of one or more outcomes. So neither this or this could really have been an outcome. It was going to have to be this. Now, you've already put an answer in for this. So it says a subset of the sample space. So this answer can't be your sample space. So it has to be event. And then this one, by process of elimination, is going to be your sample space. Again, knowing them is obviously better. I'm just giving you a way to work through it if in the exam. So on to question 9 then. Jer flips a coin 3 times. Each time he gets heads or tails. So if you flip a coin, you have an equal chance of getting a head or a tails. The diagram in the below shows how he can get each of the 8 different outcomes. So complete the table below for each of the following. Write in the missing letters H or T in the diagram. Write in the 5 missing outcomes, and then write in the number of heads in each of the outcomes. Okay, so here he is, and here he flips his coin. So here he is, he flips his coin. He has a 50% chance of getting a head and a 50% chance of getting the tails. So we'll go from here first. If he flips this coin, he has a 50% chance of getting a head and a tails. Whatever he flipped this time didn't matter. So this result is completely independent of what he did before. So this is the head or a tails. When he throws it again, it's going to be a head or a tail. So this is going to be H, H, T. That's going to be H, H, T, and it's going to be 2. This is going to be HT, and then this is going to be THT. So it'll be HTT. And the number of heads in this is going to be 1. This is going to be a tail. It's going to flip it. He says a 50% chance to get a head, he's a 50% chance to get a tails. When he throws this, he's a 50% chance to get a heads and a 50% chance to get a tails. And again, a head or a tail here. So this is tail, head, tail. This is tail, tail, head. And this is tail, tail, tail. Now, in this, he has 2 heads. In this, he has 1 head, and 0 heads. So that is done for all that. Each outcome is equally likely. Fill in the table below to show the probability that juror gets each of a given number of heads. So there's 8 possible outcomes. So we've 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. We already know that from the top. So there's 8 scenarios that he can end up with. Now, if he ends up with 0 number of heads, there's only 1 scenario he can do that. So there's 1 divided by 8. That's your first one. There are 3 scenarios out of 8 where he can end up with just 1 head. So that's going to be 3 divided by 8. There is 3 scenarios where you can end up with 2. So 1, 2, 3. And there is only 1 scenario where he can end up with 3 heads. And this makes sense because these 4 numbers together are going to equal 1, which is 100%. So that makes sense. Fidelma flips a coin 8 times. Each time she gets a head or a tails. Write down the number of outcomes that can have no heads. Well, if she flips a coin 8 times, there's loads and loads and loads of different scenarios what she can get. But there is only 1 scenario which you could possibly throw where if she flipped it 8 times, she'd get no head at all. And that number is going to be 1. So there's only 1 scenario. Because again, for what she was doing, if you consider this loud, there's only 1 path along the bottom where she could possibly end up with 0. So work out the number of outcomes where she has only exactly 1 head. So think about this for a second. If we look at this one and we did it for 8 times. So we look and we have, she had a tail, a tail, a tail, a tail. So that's 4, 5, 6, 7, and she eventually throws a head. Now, I'll do it for 1 more line. So it's a tail, 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 head, tail. So we can see that this is going to go in this format. So it's going to be a head, a head, a head, a head, a head, and a head. So there is 8 scenarios where she could possibly do that. And that's the easiest way to work it out in your exam. Imagine like what it would be like for 1 scenario and then see how it's going down that way. Work out the total number of outcomes when Fidelma flips the coin 8 times. So that answer is going to be, so if we did it this way, right? For this one, we did 3 times. So it was 2 to the power of 3, which was 8. So it's going to be 2 to the power of 8, which is 256. And that's it. Hopefully that's pretty clear. Question 10. Work out the circumference of a circle with a diameter of 8 centimeters. Give your answer correct to 1 decimal place. So the first thing we need to do is we need to work out the circumference when the diameter is equal to 8. So we're going to go to our maths tables. And we're going to go to the circle equation. Now the length of a circle, or the perimeter, essentially, of a circle is 2 pi r. So we have 2 pi r. Now here, we know our diameter is 8, so our radius must be 4. So if we sub that in, it's going to be 2 pi 4 or 8 pi. And working that out, we're going to get 25.1 centimeters. So that's going to be 25.1 centimeters. And says give her to 1 decimal place. So we've done that. The rubber track for toy digger goes around 4 circular wheels of 8 centimeters, as shown. Calculate the length of the rubber track that goes around the 4 wheels. Give your answer correct to 1 decimal place. Now, we've already found what this length and this length was equal to. So they were equal to 25.1. And now I know that this is 4, this is 8, this is 8, and this is 4. So it's going to be 4 and 4 is 8, plus 8 is 16, plus 8 is 24, and 24 by 2 is going to be 48. So it's going to be 24 by 2 is equal to 48, plus 25.1, and that's going to be 73.1 centimeters. And again, it says give our answer correct to 1 decimal place, so we're good there. Every time the wheel turns fully, the digger travels a distance equal to 1 wheel's circumference. Work out how many times each wheel will turn when the digger travels a distance equal to the length of its rubber track. So we're trying to find out each time the wheel turns 1. So every time this goes from here to here. Every time the wheel turns fully, the digger travels a distance equal to 1 square's length. So we're to know that when the wheel turns, the digger goes equal to 1 turn, or 1 wheel's circumference. Work out how many times each wheel will turn fully when the digger travels a distance equal to the length of the rubber track. So you're trying to figure out the length of the rubber, or how far it will travel when it's equal to the rubber track. So basically what you do is you just divide the total length of the track, which is 73.1, by the length of, or by the perimeter or the circumference of the wheel, and that is 25.1. And that answer is going to be 2.9 turns. So when that turns 2.9 times, it's going to be equal to the length of the track. I hope that's clear. So the next thing, in the diagram below, 2 of the sides have a length of s. So that's fine. Where s is greater than 0 and less than 6. So all angles are 90 degrees or 270. So we know that's 90, that's 90, that's 90, and these are all 90. So that's fine. Find a formula in algebra for the area of this shape. So if this was a full rectangle, it would be 10 multiplied by 6. And that would imagine that this space was here. So we need to take it away from s multiplied by 6. Because if we're taking a full triangle and taking away the area from this. So it's going to be 16 minus s squared. Because we've taken the area of one triangle, of bigger triangle, and then minus the smaller one. Yeah, and that's basically your equation. So 16 minus s squared. Show that or explain why the perimeter of this shape is always equal to 32, no matter what the value of s. If we're going to do the perimeter, it will be 10 plus 6 plus 10 minus s. So this length, this length is going to be 10 minus s, because it's this minus this. So plus 10 minus s plus, I'm going to go down this way now, and that's going to be 6 minus s So this length is now 6 minus s, and then plus s plus s. So that is going to be 10 plus 6 plus 10 minus s plus 6 minus s plus s plus s. That is going to cancel with that. That is going to cancel with that. And you're going to be left with 32. So no matter what value of s you have, you're always going to be left with 32. I hope that's clear. So basically you just sub in the values that you have for the perimeter and work it out. And that should be pretty clear. All right, then on to question 12 and 13. So prove that each exterior of a triangle is equal to the sum of the interior opposite angles. So you're trying to prove rather, so prove that each exterior angle of a triangle so pick this one, is going to be equal to this. So, I'm going to call this B, A, and I'll just call this C for argument's sake. So what you're trying to show is the angle of A plus the angle of B is equal to the angle of X. That's what you're trying to prove. And then the proof essentially is the angle of X plus the angle of C is going to be 180 degrees. Now you're going to say that a triangle, or three angles of a triangle, is equal to 180 degrees. So you could say, so following on from this first one, you could say C, or X rather, is equal to 180 minus the angle of C. And you could also say for this, the angle of C plus the angle of B plus the angle of A was equal to 180 degrees, or angle B plus angle A is equal to 180 degrees minus the angle of C. And now these two things are equal to each other. So your RHS is equal to your left-hand side, and that is true. So you're done. Okay, use trigonometry to work out the value of X in the following diagram. So here you have 6 and 20 degrees. So this is going to be a 90-degree angle. So this is going to be your opposite because your angle is here. So this is going to be your adjacent, and this is going to be your hypotenuse. So you're going to go, you're looking for this, you have this. So it's going to be your tan, because your tan of alpha is equal to your opposite over your adjacent, or your tan of 20 is equal to 6 over x. So cross multiply them. So it's going to be x tan 20 is equal to 6. X is equal to 6 divided by tan 20. So x is going to be equal to 16.48. And we're not told any units, so 16.48 will be fine. A different right angle triangle is shown on the right. It has sides of length A, B, and C. One of the angles is Y. In this triangle, AB is greater than C. So A plus B is greater than C. Use this to prove that cos Y plus sine Y is greater than 1. So what I'm going to do is I'm going to look for cos Y. So cosine of Y So I'm going to assume that this is true first, right? So cosine y, this is your 90 degrees, and this is your angle. So this is going to be your adjacent. This is going to be your opposite. And this is going to be your hypotenuse. So I'm going to write these in. So it's going to be cosine is equal to, and what I teach is Tom on a ship of his caught a herring. So it's going to be C-A-H. I'm sure you've heard Sokotoa or something else before. And then sine is going to be opposite over hypotenuse. So cosine y is going to be equal to, in this instance, it's going to be A over C, because that's my adjacent and that's my hypotenuse. So that's going to be A over C. And sine of y is going to be my opposite. So it's going to be B over C. So I'm going to substitute those things back in. So I'm going to say A over C plus B over C is greater than 1. Now, if I multiply all sides by C, so that's going to be AC over C plus BC over C is C, and then they're going to cancel. So I'm going to be left with A plus B C, which is the same as this. So this must be true. So everything is true. Yeah, so that's that one. Hopefully that's pretty clear. All right, so the last question then, we're told a cylinder is a radius of r centimeters. So this is going to be r. The cylinder is melted down and made into a cone. The cone is a radius of r and it is a height of h. So this cylinder is melted down into a cone. The cone is a radius of r. So this is still r. And this height is h. 10% of the volume of the cylinder is lost during this process. Work out the percentage increase in the height of the cylinder when it was made into a cone. So now I'm going to go to my maths tables. And I'm going to go to the volume of a cone, which is a third pi r squared h. And the volume of a cylinder is pi r squared h. So this is pi r squared h. The cone is a third pi r squared h. And the volume of this as is, so vol as is, pi r squared h. And the volume of this as is a third pi r squared h. Now we know that when the cylinder is melted down, it loses 10%. So what we're effectively saying is 90% of this is equal to 100% of this. It's going to be 0.9 multiplied by pi multiplied by r squared, which I don't know, multiplied by h is 10, is equal to a third pi r squared h. And I don't know my h of this, because I know the height of this is 10, but I don't know the height of this. So that is going to cancel with that. So the both sides are going to go. It's going to end up with 9 is equal to a third h. So divide both sides by a third. So that's going to be 27, basically 27 is equal to h. So the height of this cone is 27. Work out the percentage increase in the height of the cylinder. So it's going to be our new height, which is 27, minus our old height, which is 10, divided by our original height. So that's going to be 17 divided by 10, which is going to be 170%. It's going to be 1.7 multiplied by 100, which is 170%. So your height has increased 170%. And that's it. Hopefully you found this informative. I will be posting many of these videos over the next few weeks. You can catch me at a Facebook page at More Learning Limited. If you subscribe to that, you will see any notifications when I put up new content. I'll be trying to answer most of the junior cert papers going forward, at least the next 10 to 15 years. So hopefully that you'll find examples in that you will find useful for your studies. So subscribe, and thank you for your time. Goodbye.